techniques are commonly used to study the crystal structure of alpha-non-2, and how do these methods help in understanding its behavior in sodium-ion batteries? How does the presence of sodium vacancies affect the electrochemical properties of alpha-non-2, and can these vacancies be controlled or optimized for better performance? What doping strategies have been explored to enhance the structural stability and electrochemical capabilities of alpha-non-2? How does the interlayer spacing in alpha-non-2 impact sodium-ion mobility, and are there ways to optimize the spacing for improved performance? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What challenges exist in synthesizing alpha-non-2 with a uniform and defect-free crystal structure, and how do synthesis techniques impact its final electrochemical properties? How does alpha-non-2 compare to other sodium-based cathode materials in terms of structural stability and electrochemical performance? Are there alternative structural modifications that could improve the sodium-ion intercalation and deintercalation processes in alpha-non-2? How does the presence of water or other environmental factors affect the crystal structure and electrochemical behavior of alpha-non-2 in practical applications? How does the working voltage range of Na/Non-2 spanning from 2.0 to 3.8 V influence its overall electrochemical performance? What role does the low current rate of C/10 play in determining the specific capacity of Non-2 during the first cycle? Why does Non-2 exhibit a high initial specific capacity of approximately 185 mAh G⁻1, and what factors contribute to this value? How does the specific capacity decline to around 150 mAh G⁻1 by the 10th cycle, and what mechanisms drive this attenuation? Why does the capacity fade become more pronounced with an increasing number of cycles, and what structural or chemical changes are responsible? What insights can be derived from the charge/discharge curve of Non-2 regarding its electrochemical behavior? How does the presence of multiple voltage platforms in the discharge process indicate severe phase transitions within the O3 type Non-2 material? Why are these phase transitions considered a primary factor in the material's poor cycling performance? What are the specific phase transition mechanisms occurring in Non-2 during charge and discharge cycles? How do these transitions affect sodium-ion diffusion and overall battery efficiency? What structural characteristics of O3 type Non-2 contribute to the observed voltage platforms? How does the evolution of the crystal structure during cycling impact its stability and specific capacity retention? In what ways does the interaction between sodium and manganese ions influence the electrochemical behavior of Non-2? Are there external factors such as temperature, pressure, or electrolyte composition that accelerate phase transitions and further degrade cycle life? What?